In your incoming Math 101 exam, if you come across these questions in your exam, how are you going to solve them? They are very easy, okay? So welcome back to this channel. In this video, I'll be solving a lot of questions on Math 101, and the important thing is that these questions are usually repeated questions, okay? And apart from that, I'll also be showing you guys how to use calculator to solve questions on topic like trigonometry as well as complex number. Okay, now let's start with the very first question in this class. Very first question, which is question 1. They said find the expression for the last term un. Okay, that is the last term. They say find the expression for the last term of the sequence 3, 5, 7 and 9. So this question is coming out from AP, which is at arithmetic progression. Okay, so they're asking us to look for the last term. So the formula to calculate for the nth term of an AP, this is the formula. Okay, yes, the formula to calculate for the nth term, the nth term of an AP, this is the formula. While for a GP, this is the formula to calculate for the nth term of a GP. Okay, so if you look at this question is coming out from an AP, okay, which is an arithmetic progression, and they're asking us or telling us to look for the last term, which is very easy. Now let's write down the sequence. The sequence is what? Sequence is 3, 5 and 3, 5, 7, 9. Okay, so these are the numbers, these are the sequence. Okay, so now this is the formula to look for the nth term of an AP. Now this letter here you see here is what? Is the first term. Okay, this one is known as this A is known as the first term. Then this N is known as the term number. Okay, this is very important. N is known as the term number. Then D is known as what? D is known as the common difference. Okay, the common difference. Okay, why this one is known as what? Is the nth term, right? Yes, the term they are telling us to look for. Okay, so the first term, if you look at this sequence of number 3, 5, 7, 9, which one comes first? Is 3, right? So 3 is what? 3 is the first term, right? The first term, which is A. 3 is the first term. Okay, yes. Now if you look at the question, it said find the expression for the last term of the sequence. Okay, so A is what? The first term. Now let's look for D. What is D? D is the common difference. Now what is the difference between 5 and 3? The difference between 5 and 3 is what? Is 2, right? That is, if you look at it, 5 minus 3 is equals to what? 2, right? Now what is the difference between 7 and 5? 7 minus 5 give us what? Give us 2. What is the difference between 9 and 7? 9 minus 7 give us 2. So the common difference in this sequence is what? The common difference is 2, right? Yes. The first term is what? The first term is 3. The common difference is 2. So in the question they are telling us to look for what? To look for the expression. Say we should look for the expression to calculate the last term. Yes, so which is very easy. So we do something like this. Okay, the nth term of an AP is equals to the first term. Where is the first term? The first term is what? The first term is 3, right? So 3 plus bracket open. Now they didn't give us the tenth. They didn't give us the term number, so we just put in there. They're asking us to look for. They're asking us to look for the. They're asking us to look for find the expression for the last term. Okay, so n minus 1 bracket close. Now what is the common difference? I've told you guys, common difference in this sequence is what? The common difference is 2, right? Yes. Now if we continue, 2 times n give us what? We give us 2n, right? 2 times minus 1 give us minus 2. Then plus this 3 is equals to u. What's the n terms, right? Yes. Now if we continue, if we rearrange this, we have something like this. Okay, 3, 2 can come towards that, right? So minus 2 then plus 2n, right? Yes. So we continue. 3 minus 2 give us what? Give us 1, right? So we're left with what? 1 plus 2n, right? Therefore, we have something like this. The end term of this sequence is equals to what? it's equal to 1 plus 2n, or we can say 2n plus 1. So this is the expression to calculate for the last term of this sequence. Okay, so if you look at the board, the answer is what? The answer is B, right? So 2n plus 1. So for this first question, the answer is what? The answer is B. Okay. Now let's move to the next question. Okay, so the next question they said evaluate sigma 7 r equals to 3 2 raised power r. Okay, so now let me explain this. Now let's say we should evaluate this. This question is very, very easy. So if we continue, okay, 2 r raised power r, right? Then 7. Okay, now this one means sigma or summation. It means summation or sigma. Okay, why this 3 is known as the starting value. Okay, 3 is known as the starting value. Then this 7 is known as the ending value. Okay, so that is just it. So wherever we see arrow here, we put what? Wherever we see arrow, we put arrow is what? Arrow is starting value. When we start with arrow, which is 3, then we end with what? With 7. That is just it. Then this symbol here, which is known as sigma, it means summation. Okay, so if we continue, it's okay. Sigma coming. If we continue, have something like this. Okay, 7 r equals to 3, then 2 raised power r is equals to 2 now raised power to the start. 3 is the starting value, right? Remember, I told you guys 3 is the starting value, 7 is what? The ending value. So let's continue. So we start with what? 3, right? Then plus, if we see continue, 2 raised power what? 4. We end with 7. Plus, because this sigma means the summation of everything, okay? Then plus 2 raised power 5, then plus 2 raised power 6, then plus 2 raised power 7 equals to, I told you guys that this 7 is the ending value, okay? So if we continue, if we add everything, let's see what will be our answer. So let's continue. 2 raised power 3 plus 2 raised power 4, then plus 2 raised power 5, plus 2 raised power 6, then plus 2 raised power what? 2 raised power 7. Okay, so our answer will be what? 248. Okay, so that's just it. So that would be our answer, which is B, 248. Okay, so now let's continue with the next question, which is question 3. They said, okay, this question, they said, Mr. Daniel got this question is coming out from an AP. Okay, so now they said Mr. Daniel got an employment offer with a starting salary. This is very important. With a starting salary of what? 500,000 per annum. This means that the salary that will be paying Mr. Daniel per year is what? 500,000. That is the starting salary is what? 500,000 per year or per annum. Okay, with a yearly increase of 20,000. It said calculate its salary at the 10th year. So this question is coming out from an AP, which is arithmetic progression. Okay, so they're asking us to calculate its salary at the 10th year. Now, if you look at this question very well, let me interpret it. They said that Mr. Daniel was offered an employment, and his starting salary, is what? Is 500,000 naira per year, right? So the starting salary for that year is 500,000. Let's say with a yearly increase of what? 20,000. So for the next year, it will be paid what? It will be paid what? 500 and what? 20,000. I don't know if you understand. So in the third year, it will be paid what? It will be paid what? 500 and what? 540,000, right? So that is what this one means. Means that, let's say with a yearly increase of 20,000. So the following year, the salary will be increasing by what? Will be increasing by what? 20,000, like, right? So they're asking us how much will they say, okay, we calculate his salary at the 10th year. Don't you understand? So that we can skip up, we can continue like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. But to just be fast, let's use the formula of an AP. Okay. Yes, we can. This is the first year, this is second, this is third year. The fourth year will be what? The fourth year will be be 560, right? Yes, the fifth year will be 580. The sixth year will be 600,000, right? The seventh year will be 620. The eighth year will be 640, the 9th year will be 660, while the 10th year will be what? 680, which is what? Which is C, right? Yes, but let's still solve it using the formula, okay? So it's very easy. Okay, so using the formula to calculate the n terms of an AP, okay, this is the first term bracket to first term bracket open, n minus 1 bracket close, right? I told you guys that this is the first term. This one is the 10th number. Why this one? I mean, this one is the term number rather. The term number. Okay, the term number. This one is the common difference. This is the first term. Now, if you look at this scenario, the first salary, which is the first salary. What is the first salary? They say the first salary is what? The starting salary is what? 500,000. So the first term is what? Is 500,000, right? Yes, it's 500,000, right? Now this one is the term number. If you look at the term number here will be what? Will be this 10th year. The 10th year. Say calculate the salary at the 10th year. So the term number will be what? Will be 10. Okay, with minus 1. Then what is the common difference? Now the common difference is what? The common difference is 20,000. How? Because why? The first year they paid in the first year they were paying what? 500,000. The second year they were paying 520,000, right? The third year they were paying what? They were paying 540,000, right? Yes. So where is the difference? The common difference between these two is 20. Because the common difference between these two is still what? 20,000, right? So that is just it. So the common difference will be what? Is what? 20,000. So times 20,000. So 10 minus 1 will give us 9, right? 9 times 20,000. Let's do it. So 9 times 20,000 will give us 180,000, right? So everything here will be what? Everything here will be what? 180,000. Okay, 180,000. So, right? Yeah. Okay. Yes, 180,000. So let's continue. 500,000 plus 180,000. Everything will be everything will be 680, right? Yes, 280,000. So that is just it. So the answer is C. Now for question 4, they said the P series is convergent if the answer is what? Is B. If P is greater than 1, it is what? It is convergent. Okay. So let's move to the next question, which is question 5. Now in question 5, they said an exponential sequence, which is known as the GP, a geometric progression, is given by what? 8, 2, half, and so on. Find in terms of n the nth term. Okay, so this is the formula to calculate for the nth term of a GP. Okay, so to calculate on the nth term of a GP is what? Is the first term multiplied by the common ratio, the raised power the term number minus 1. Okay, yes. Unlike this is just analog to a AP, because this is common ratio in AP. In AP is known as common difference. In GP is known as what? Common ratio. Okay. Yes. Now how do you look for the common ratio? Remember in AP the common difference we look for the common difference by subtracting the next term from the previous term, right? Yes. Now to this, let me just this is the first term, right? Yes, this is the first term. Okay, this is the first term. This is known as what? The common ratio. Okay, common ratio. How are we going to look for a common ratio? Look for common ratio is very easy. Common ratio is what? Is the next term divided by what? The previous term. Okay. Yes, the next term divided by the previous term will get the common ratio. But in AP, common difference, to get the common difference in AP, we subtract the next term from the previous term, right? Yes, but the common ratio, in the common ratio, we divide the next term by the previous term, right? Yes. So this one, n is known as what? N is known as the term number. Okay, the term number. Okay. Yes. So they're asking us to look for what they said. An exponential sequence is given by 8 to half. Find in terms of n. This n means that your answer will be one n being in your answer. So they find in terms of n the nth term. So we are looking for this, which is known as the nth term, right? Yeah. So it's very easy. Okay. So let's look for our common ratio first. Now to look for our common ratio. Now this is the first term, right? The first term is 8, right? So A is 8, right? The first term. Now the second term is what? 2. The other term is what? Half, right? Yes. Now let's look at common ratio. The common ratio, the previous let's with respect to 8 and 2. Now 8 is what? 8 is the previous term, right? Yes. The next term is what? Is 2, right? Yes. So 2 here 1, 2 here 4. So the common difference is what? Is 1 over 4, right? So therefore arrow is what? Arrow is what? Arrow is 1 over 4. Okay, we know that A is what? The first term. A is 8, right? Yes. Then n which is what? The term number. They said what? They said okay, 5 in terms of n. That means that n will be in our answer. Okay, so that is the term number. They didn't give us term number, so they said that 5 in terms of n will be in our answer as well. So let's continue. So it's very easy. So we are looking for what? The nth term, which is this, the nth term. So let's continue. So the nth term is equals to what? The first term is what? The first term is 8, right? Then times, now the common ratio is what? Common ratio is 1 over 4, right? Then bracket open, bracket close, raised to power what? N, right? We don't know n. Then minus what? Minus 1, okay? Yes. Now let's simplify this a little bit, okay? So now going to indices, remember 1 over 4. Remember, I'm going to indices. I told you guys that when, for example, when a raised to power minus 1 is written as what? 1 over a, right? Yes, a raised to power minus 1 is written as 1 over a, right? Therefore, 1 over a is written as what? A raised to power what? Minus 1, right? Yes. So if you look at this, 1 over 4 is still written as what? 4 raised to power minus 1, right? Yes, okay. So 1 over 4 is written as what? 4 raised to power minus 1. Now if we continue further, 4 raised to power minus 1 is still the same thing as what? 4 raised to power minus 1 is still the same thing as what? 2. Now we are working something like this, right? Now remember 4 is still the same thing as what? 2 raised to power 2, right? 2 raised to power 2, right? Yes. Okay. 2 squared will give you 4, right? Yes. So 1 over 4 is written as 4 raised to power minus 1, right? Yes. Then 4 raised to power minus 1, 4 itself, 4 is the same thing as what? 2 raised to power 2, right? Yes. So 2 raised to power 2, and these two multiplying what? That the minus 1, right? Yes. So now something like this. 2 times minus 1 will give us minus 2. So now something like this. 2 raised to power minus 2, right? Yes. So everything here will be what? Everything here will be what? Everything here will be 2 raised to power minus 2, right? Yes. If you just follow this full step, if you follow it step by step, 1 over 4 is same as what? 4 raised to power minus 1, right? Yes. 4 raised to power minus. Now let's neglect this one first. 4 itself is still same as what? 2 raised to power 2, right? Yes. 4 itself is still same as 2 raised to power 2. Then don't forget about this raised to power minus 1, right? Minus 1 times this 2 will give us what? 2 raised to power what? Minus 2, right? Yes. So that is what we did here. So therefore 1 over 4 is still same as what? 1 over 4 is still same as what? 2 raised to power minus 2, right? Yes. You understand how I did it? So everything here we'll put what? We'll put 2 raised to power minus 2, right? 2 raised to power minus 2, right? Yes. So now if we continue further, now 8 is still same as, because our answer is D. So 8 is still same as what? 8 is still same as 2 raised to power 3, right? Yes, because if you do it, it will be something like this. 2 times 2 times 2, that is 2 into 3 places, right? Which should be what? 2 times 2 times 2 will give us 8, right? So 8 is still same as what? 2 raised to power 3, right? So I'll put everything. I'll put what? 2 raised to power 3 here, right? In the place of 8, right? Yes. Now if we continue, okay. So if we, okay, let me see. Okay, now if we continue, minus 2 times, remember, okay, that's something like this, right? Minus 2 times n give us, minus 2 times n will give us, will give us minus 2n, right? Yes. Then minus 2 times minus 1 give us plus 2, right? Yes. Minus 2 times n will give us minus 2n. Then minus 2 times minus 1 give us plus 2, right? Minus 2 times minus 1 give us what? Give us plus 2, right? So everything here will not be something like this. Everything here will not be 2 raised to power minus 2n plus 2, right? Yes. So if we okay, yes, that is just it. Now if we continue, according to, if we continue, according to, I think, is it, yeah, indices, right? Yes, indices. So according to indices, when two bases are multiplying each other, we take one of the base, then we'll do what? We add their powers, right? Yes, we take one of the base. This, for example, a raised power, let's say a raised power 2 plus, okay, times a raised power 3. Now, when two bases are multiplying each other, we take what? We take one of the base, then we'll do what? We add their power, right? So 2 plus 3, right? Yes. So that's what we are going to do here. These two bases, they are multiplying each other. So take one of the base, we add their power together. So let's add the power 3 plus minus 2n plus 2, right? Yes, 3 plus minus 2n plus 2. Now these two can add up together because these two, they are not the same. So I cannot subtract 3 from minus 2. I cannot subtract 2n from 3. Cannot work. Something like this cannot work. So these two, they are the same, right? Yes. So 2 plus 3 will give us what? Will give us 5, right? Give us 5. So now something like this, 5 minus 2n, right? Yes. So 3 plus 2 will give us 5, right? So now something like this, 5 minus 2n. Okay. Yes. So that's just it. Okay, let's continue. Or you can say, okay, plus or minus will give us minus, right? Yes. So this one, we can still rearrange it as what? 2 raised power 3 plus 2 minus 2n. 3 plus 2 give us what? 5, then minus 2n. Are we done yet? No. So everything here will not be what? Everything here will not be 2 raised power 5 minus 2n, right? Yes. So if you look at all the option, you will not see the answer, you will not see this. Yeah. The one you see here is plus, and this one is minus. So if we look at this one is good to go. If we simplify it, if we simplify it further, we have something like this. Now remember, this is 2 raised to power 5 minus 2n, right? This one is still something as what? It's still something as what? 2 raised to power 5, then then okay, 2 raised to power 5 then times 2 raised to power minus 2n, right? Yes, it's still the same thing. Because why? Because according to indices, because we know that according to indices, when the same base, when they are multiplying each other, we do what? We take one of the base, we do what? We add their power, right? 5 plus minus 2n. Remember, 5 plus minus 2n give us what? Give us minus 2n, right? So we have gotten this one back. So it's the same thing. So this one is still the same thing as what? 2 raised to power 5 times 2 raised to power minus 2n. I don't know if you understand. According to indices, so these two bases are multiplying each other. We'll take one of the base, we'll do what? We add their power together, right? So plus and minus will give us minus, right? So now we'll see get this thing back. So it's the same thing, okay? So 2 raised to power 5 minus 2n, we see something now, 2 raised to power 5 times 2 raised to power minus 2n, right? Yes. Now remember, 2 raised to power 5 is the same, is what? If you look at it, checking your calculator, 2 raised to power 5 is 32. 2 raised to power 5 is what? Is 32. So we have something like it will now be 32 bracket 2n bracket 2 raised to power minus 2n. Wow, long process. So the answer is D. Okay, so the answer is D. Okay, yes. So 2 raised to power 5 is same as well, is 32. Then bracket open, which is times, right? Bracket close, these two, then raised to power minus 2n, right? Yes. So this is the answer. Okay, yes, this one is still same as what? It's same than 32 times 2 raised to power minus 2n, right? Yes. So in the place of this multiplication, just put bracket, right? Yes. So bracket means multiplication, right? Yes. So that is just it. So it's part 2n. So this is how to solve this question. Question is D. So don't think that is B, because why? B is not correct. Had it been is minus, that would be correct, but B is not the right answer. The right answer is D. Now let's move to the next questions. All right. So let's continue this next question. Question 6. This question is coming out from binary operation. Okay, so they say the binary operation is defined on a set of three numbers arrow by a operation b is equals to b squared minus a squared divided by 2ab. Find 3 operation 2. This is very easy. Okay, now it's just easy. If you look at it, they said the binary operation is defined on a set of three numbers arrow by what? by A operation B. They give us, if they say A operation B is equals to B squared minus A squared divided by 2AB. They say find 3 operation 2. Now it's very easy. If you look at it, A is what? Substitute A with 3. Then substitute B with what? With 2. That is, A is 3, B is what? 2. So wherever you see A, you put 3 there. Wherever you see B, you put 2. A is 3, B is what? B is 2. So that is just it. Now they said that A operation B is equals to what? They say A operation B is equals to B squared minus A squared divided by 2AB. Now, what is B? B is what? B is 2, right? So we'll put 2 there. 2 raised power what? 2, right? Yes, minus A is what? A is 3, right? So 3 squared divided by what? 2 times A is what? A is 3. Then B is what? B is 2. Right? So if we do everything, 2 square is 4. 3 square is 9. Divided by 2 times 3 is 6. 6 times 2 is 12. So therefore we have something like this. 4 minus 9 will give us minus 5, right? Then divided by what? 12. So the answer is 1 minus 5 over 12. So the answer is B. Okay, so it's very easy. So now the answer is B minus 5 over 12. Okay, minus 5 over 12. Now let's move to the next question, which is question 7. Okay, so we see this question under binary operation are very easy. Okay, so now let's continue with the next question, question 7. They said the binary operation is defined on a set of real numbers arrow by x operation y. Okay, by x operation y is equals to root s plus y minus root s then minus y. Okay, they said where the value of now operation 2 is. So let's tell you that just like the one we did earlier, let's tell you that s is 9, y is 2. So wherever we see s, we put 9. Wherever we see y, we put 2. So it's very easy. So s operation y is equals to root s plus y minus root s minus y. So don't forget that s is 9, right? So wherever we see s, we put 9. Okay, then plus y is 2, then minus s is what? S is 9, right? Then minus y is what? Y is 2. Okay, so if we continue, root 9 will give us what? Root 9 will give us 3, right? 9 plus 2 will give us 11. So root 9 is 3, then minus 2. Okay, so we do everything. Don't forget about the square root. Let's not forget about the square root. Okay, so if we do everything, 11 minus 3 minus 2 will give us 6, right? So the answer is what? Everything here will give us 6. So the answer is root 6, which is A. Okay, so the answer is A, which is root 6. Now let's move to the next. The next question is question 8. Question 8 is still under binary operation. Okay, they said the binary operation. Okay, I'm coming. Now the binary operation is defined on the set of real numbers arrow by I'm coming. Let me clean this place. Okay, so it's defined on the set of real numbers arrow by A operation B is equals to A plus B plus half AB. Okay, they said find. They said look for. They said find 2 operation 3 then operation 4. Now if you look at this one, it's kind of different from the one we have been doing. If you look at the previous one, they will just give us something like this, and 2 operation 3, A is 2, B is 3, right? When you look at this one, they had another number, operation what? Operation 4. So how are we going to do this? It's still very easy. So how are we going to do it? We'll go to use this tool to solve first. Once we solve, the remaining thing we have, then once we solve, then we use the remaining thing we have. We now, okay, I'm coming. Yes, we use these guys to solve first. Yes, once we use these guys, these two to solve, then we'll now use this other one too. Let me tell you. Now let's do it. Remember, let's use this 2 to solve first. Let's neglect 4. Okay, so that's tell you that A is 2, then B is what? 3, right? So wherever we see A, we put 2. Wherever we see B, we put 3. So that is just it. So A operation B is equals to A is what? 2, B is 3, then plus half A is what? Times, okay, A is what? 2, right? Then B is what? 3, right? So we do everything. 2 plus 3, that is 5. Then 2 times 3 is 6. 6 times half is 3, right? Yes. So everything will now be what? 8, right? So we have what? We have 8, right? Yes. Our answer will now be what? 8 operation what? 4, right? Yes. So this is what we got, right? We got 8, right? We got 8 when we use this to, right? Yes. Now this we got 8. Then we'll now do like this 8 operation 4, right? We'll now solve again. Let me understand. We'll now solve again because of this 4. We'll now need to solve again. Therefore, our A will now be 8. Our A will not be 8, our B will not be what? Will not be 4. So let's solve again using 8 and 4 next. So it's just easy. Our A is what? Our A is 8, our B is 4. So if we do it, A operation B is equals to A is what? A is 8, right? B is what? 4. Then plus half, A is what? Times A is what? 8, right? Then B is what? 4. So we do everything. 8 plus 4. This is 12, right? Then plus 8 times 4. I think that's 24, right? 8 times 4 is 24. I mean, it's 32. Then times half, we give us 16. So 16, so everything here will be what? 16, right? Yeah, so 16 plus 12 is 28. So our answer is 28, which is A. Okay, yes, which is A. So that is just it. All right, so now let's continue with partial fraction. Okay, now if you look at this question, they said express s plus 7 divide s square minus 16 into partial fraction. Okay, yes. Now when we solve this question, we need to tell you guys how to solve questions under under partial fraction. Now there are different categories of partial fraction. Okay, now when one of the category is distinct linear factor. Now when the denominator are a linear factor. Well, what do I mean by linear? When the highest power of s is 1, right? That is s is not s square. I don't know if you understand. So when the highest power of s is 1, so this is a distant linear factor. Okay, yes. Now when you see fraction like this, normally when you see fraction like this, it is usually broken down into into this form. I don't know if you understand. Forget about this numerator. Forget about numerator. This is usually broken down into A over this denominator, then plus B over this denominator. I don't know if you understand. That is when it is a linear factor. When I mean by linear, that is when s does not carry square. Okay, yes. Now, so that's to tell you that if you have something like this, 9 plus 8 divided by let me say s plus 4 divided by s minus 2. And if you have something like this, if you decompose it, we do it like this, to be A over this first denominator s plus b, then plus b over this second denominator s minus 2. I don't understand. That is when the highest power of s is 1. Okay, that is linear factor. Okay, so this type of partial fraction is this one under distinct linear factor. Okay, yes. Now now we still have another one which is repeated linear factor. I don't understand. Repeated linear factor such as this. Now this one, the highest power of s is still linear factor because the highest power of s is still 1. S is raised to power 1, right? S is not raised to power 2 or NTS. That is, I'm talking about the denominator. Forget about the numerator. Okay, yes. When you have repeated linear factor, how do you know repeated linear factor? Usually see square here. Let me understand. So if you want to decompose this fraction, it could be something like this. I'm coming, for example, I want to decompose this partial fraction, for example, to be something like this: a divide s minus a, then plus b divide s minus a, then all square. I don't even understand. For example, now let's say, for example, it is raised to power 3. It will be something like this: a over s minus a plus b over x minus a all square, then plus c over s minus a all cube. I don't even understand. When it is raised to power 4, for example, it will be what? Plus d raised to power s minus a raised to power 4. I don't even understand. So that is just it. So there are different categories of partial fraction. Okay, yes, these two are linear factor because where the power, the highest power of s here is 1. Okay, yes. So now let me say for example, you have a partial fraction of let's say 2 divide s plus 2 plus 3 divided by s minus 2. Okay, no, let's say we have partial fraction like this. For example, raised to power 3. Now if you want to decompose this partial fraction, it will be something like this. It will be something like this: a divide s plus 2, then plus b divide to be what, s plus 2 raised to power 2, then plus c divide what, s plus 2 raised to power what, 3. I don't even understand because why? Because this is, we repeat it 3 times. S plus 2. Then now it will be s plus 2 raised to power 2. The last one will be what, s plus 2 raised to power 3. Whereby it is something like this, raised to power 2, it will be something like this. Let's say we have let's say you have a partial fraction like this: 2 divide s plus 2 raised to power all square. If you want to decompose this, it will be like, it will be something like this: a divide s plus 2 plus b divide s plus 2 all square. So that is just it. Okay, so that is just it. So that is for repeated linear factor. To decompose it will be something like this. For distinct linear factor, to decompose it will be something like this. Then for distinct quadratic linear factor, for distinct quadratic factor, how do you know quadratic factor? I think we should just forget about this one, okay? To just save time, because let's just deal with these two. Okay, yes. So let's say that when it is in linear factor, decompose it to just be a over s minus a. So you will see it by yourself. Now let's try this very first question. They said express s plus 7 divide s square minus 16 into partial fraction. So we have something like this: s plus 7 divide what, s square minus 16, right? Yes. Now let's decompose this partial fraction. Okay. Now do you know that this s square minus 16 is still something as what? It's still something as s. It's still something as s. It's still something as s. Okay. Because we have what, s square minus 16, right? It's still something as s square minus 4 square, right? Yes. Right. Yes. Now s square minus 4 square is still something as what? It's still something as s minus 4 all square, right? Yes. So therefore this one is something as this, right? So therefore put something like this: s minus 4 all square, right? Yes. So we have successful, we have gotten something like this, right? I want something like this, right? Yes. Okay, I'm coming. No, if we go back, I'm sorry. Now this sentence as what, s square minus 4 square, right? Yes, s square 4 square give us 16, right? Yes. Now if you look at these two, this is what, this is a difference of what, 2 square, right? This is a difference of 2 square, right? Yes, difference of 2 square, which is equals to what, s difference of this of 2 square, which is sent as s minus 4 all raised to power square, right? All raised to power 2, right? Yes. And this one means that s minus 4 all square, it means that s minus 4 is multiplying s plus 4. This is a difference of 2 square. Okay, yes. So that is it. So everything here is still something as well this. So therefore I'll put everything here will be what? Everything here will be s minus 4 then s plus 4, right? Yes. So therefore our partial fraction is what? Our partial fraction is s plus 7 divide what? S minus 4 then s plus 4, right? Yes. Now if you look at this and this, if you compare which one is under, this one is under this linear factor, right? Yes. Now for this linear factor, for this linear factor, this under this linear factor, we usually when we decompose, we usually a over the denominator, right? Now if you look at this, we decompose it to be what? To be a divide this one, s minus 4, then plus b divide this one, s plus 4, right? Yes. I don't even understand. So let me clean here. I'm coming. So therefore we have something like this: s plus 7 divide s minus 4 bracket open s plus 4 then is equals to what? A over s minus 4 plus b over s plus 4. Okay, yes. This is how we decompose. So this is how to decompose partial fraction. Okay, yes. So just forget about the numerator. Just focus more on the denominator. When you have something like this, it means if you want to decompose it, to be what? It will be a over this one, then b over this other one, right? Yes. So what next? We want to look for a. We want to look for a. We don't know a. We don't know b. I don't know if you understand. Okay. Yes. We don't know a. We don't know b. So what are we going to look for a? Let's say we want to look for a, so it's very easy. So what I'm going to do next, we'll multiply everything. Multiply everything by what? Multiply everything by s minus 4 and s plus 4. We multiply everything that this denominator. If we multiply everything, if we multiply everything by this, if this multiply this, this one will cancel this, right? We'll be left with what? S plus 7, right? Yes, then equals to, I don't understand. If this multiply everything, if this one multiply this, see, let me just say, okay, s plus 7 divide s minus 4, then s plus 4, then all multiplied by s minus 4, s plus 4. You find out that this one will cancel this one will cancel this. We'll be left with us s plus 7. So these are self partial fraction. S plus 7, right? Now this one we see multiply everything here, we multiply a over s minus 4, right? If everything multiply a over s minus 4, we have something like this. If everything multiply, this one cancel this, we have what? We have something like this: s plus 4 times a, right? Yes. So s plus 4 times a, we have what? We have a bracket open, s plus 4 bracket close, right? Yes. Then what about b? If everything multiply b, this one will cancel this, right? This one will cancel this. We'll be left with what? S minus 4. S minus 4 times b, we have a b bracket open, s minus 4 bracket close, right? Yes. So we have gone like this, right? We want to get a and b. Once we get a and b, put it here, we get our what? We get our partial fraction, right? Yes. Now, let's look for a first. Let's look for a first. Now, in order to look for a first, now we make b 0. I don't understand. Now look for a first, we make b 0. Now, what can make b 0 here? What can make b 0? That is when we make s 4. If we make s 4, make s 4, here will be 4. 4 minus 4 give us 0. 0 times b will give us 0, right? Yes. So when we make s 4, we turn b to 0, right? Yes. So we let s make s to be what? Make s equals to 4, right? Yes. So wherever we see s, we'll put 4. So 4 plus 7 is equals to a bracket open. S is 4, right? Plus under 4 bracket close. So this is what? 8. 8 times a will give us 8. 8 then is equals to 4 plus 7 will give us 11. Therefore, a will be equals to what? Divide both sides by what? By 8, right? Therefore, a will be what? A will be equals to 11 divided 8. So this is a. Now, we are gotten a to be what? We are gotten a to be, our a is equals to 11 divided 8, right? Yes. Now, what about b? Now, we go back to that former equation that we get previously. We know that b was formerly what? Minus s minus 4, right? Yes. Now let's get b. In order to get b, we need to make a 0, right? Yes. Now what can we do to a that will make a to be 0? We'll make s to be minus 4, because if we have minus 4 here, minus 4 plus 4 will give us 0, right? Yes. So we'll make s minus 4. If we make s minus 4, minus 4, s will be minus 4. Minus 4 plus 4 give us 0, right? So 0 times a will still give us what? Give us 0. So we'll be left with what? We'll be left with s plus 7 is equals to b bracket open s minus 4. Now don't forget that s is minus 4, right? So wherever you see s, we put what? Minus 4 then plus 7 is equals to b bracket open. S is what? Minus 4, right? So minus 4 minus 4 give us minus 8. Minus 8 times b give us minus 8b, then is equals to minus 4 plus 7. Now, minus 4 plus 7 is what? Is 3. Okay, so minus 4 plus 7 is 3. So therefore, we have 3 equals to minus 8b. What I'm going to do next is that both sides by what? Minus 8. So if that both sides by minus 8 cancel this. Therefore, b is what? B is minus 3 over 8. So therefore, our a is what? Our A is 11 over 8, then our B is what? Minus 3 over 8. Okay, so that is just it. Now let's put, I'm coming. So our A is what? 11 over 8, then our B is what? Minus 3 over 8, right? So we'll impute it inside here. So therefore A is what? A is what? A is 11 over what? 8, right? A is 11 over 8, then bracket open, S minus 4, right? Then plus B is what? B is minus 3 over 8, then this S plus 4, right? Now don't forget B is minus 3 over 8, right? Yes, minus 3, I'm coming. Minus 3 over 8, then times 1 over S plus 4 will still give us this. Okay, yes, I don't even understand. A is what? 11 over 8, right? So if you put 11 over 8 here, we have to like 11 divided 8, then times this one, 1 over S minus 4. So 11 times 1 give us 11. 8 times S minus 4, we will get what? We have 8 bracket open S minus 4. I don't even understand. So that is it. So these are our answer. Now we don't forget to have minus. A minus times plus give us minus. So this is the partial fraction, which is, I think that is B. Okay, that is B. Okay, so it's very easy. Now let's do another question from past question under partial fraction, so you can understand more better. Now let's solve this other partial fraction. Okay, they said express this into partial fraction. Okay, yes, it's very easy. Okay, so 8s minus 17 divided by bracket open S plus 1 bracket close bracket open S minus 4, right? They said we should express it into partial fraction. Like what I told you guys earlier, this is under a distinct linear factor, right? Yes, which when we decompose it, it will be something like this. Forget about numerator. Okay, it will be something like this. It will be something like this. A divide what? This one, right? S plus 1, then plus B divide what? S minus 4. That is how you decompose this type of partial fraction, because this one is on this type of fraction is under a distinct linear factor. Okay, so yes, there are 3 categories. When it is distinct, something like this, but when it is repeated, it will be something like this: S plus 1 all square. Now you want something like this. You want something like A over S plus 1, then plus B over S plus 1 all square. If it's 3, to be plus C over S plus 1 cube. If it's 4, plus D over S plus 1 raised to power 4. So that is just it. Okay, now but this one is not, this type of question is not a repeated. This one is a distinct linear factor where the highest power of S is 1. So to do this at first, to do this about thing, decompose it first. How do we decompose something like this? A divide this denominator plus B divide what? This denominator. I don't understand. The next thing we are going to do is what? We are going to multiply everything by what? By this denominator, by what? By S, by what? By S plus 1 bracket close bracket open S minus 4. We are going to multiply everything by S plus 1 bracket open S plus 1 bracket close bracket open S minus 4. I don't understand. So if you multiply everything by this, and let's do it. Let's multiply it. 8s minus 17 divided by S plus 1 bracket close bracket open S minus 4, then all multiplied by, let's multiply everything by this one, by S plus 1, then S minus 4. This one will cancel, this one will cancel, this will be left with what? 8s minus 12, right? 8s minus 17. Okay, so we'll be left with 8s minus 17 this side, right? Yes. So if you multiply everything, we are not done yet too. So here will be what? 8s minus 17, right? Yes. Now if you multiply A over S plus 1 by S plus 1 and S minus 4, this one will cancel, this will be left with what? We'll be left with S minus 4. S minus 4 times A will give us what? Give us A bracket open S minus 4, right? Yes, then plus. Now if we, if we multiply this one by this, this one will cancel this. We'll be left with S plus 4, S plus 1. S plus 1 times B will give us what? Will give us B bracket open S plus 1, right? Yes. What I'm going to do next, simple, we look for what? One, we want to look for, we don't know A, we don't know A, we don't know B. I don't even understand. So we want to look for A and B. So let's look for A first. Now, in order to look for A first, we need to make B 0. I want to make B 0. Let's make S. What will make, what are we going to add to 1 that will make everything here 0? It will be minus 1. Minus 1 plus 1 will give us 0, right? Yes. So what are we going to add to make here 0 is minus 1, right? Yes. Let's say, for example, here is 2. What are we going to add to here to make here 0? To be what? To be minus 2. Minus 2 plus 2 give us 0, right? Yes. But here is what? Here is 1. So to make everything 0 here, we'll make S to be what? Minus 1, right? So everything here, S every year will be what? Minus 1. So therefore, to be what? 8 bracket open, S is 1 minus 1, right? Bracket close, then minus 17 equals to A bracket open. S is what? Minus 1, then minus 4, bracket close, then plus B bracket open. S is 1 minus 1, then plus 1. Minus 1 plus 1 give us 0. So 0 times B give us 0. So we have removed B. Then we have something like this. Minus 1 minus 4 will give us minus 5. Then A. 8 times minus 5 will give us what? Will give us minus 5A, right? And is equals to, now, minus 1 times 8 will give us minus 8. Then minus this 17, right? Yes. So minus 8 minus 17. Minus 8 minus 17 will give us minus 25. Okay, so everything here will be what? Minus 25 is equals to minus 5A. This minus cancel this minus. We are looking for A, we divide both side by 5. So if we divide both side by 5, A will be what? A will be 5. So our A is what? Our A is 5. Okay. Now let's look for B. Now, in order to look for B, our A is what? We already get our A. Our A is what? Our A is 5 already. Now, we want to look for B. In order to look for B, we need to make A 0. So what are we going to make? What are we going to make S? Like what is the S going to be in order for everything here to be 0? S is going to be 4 or plus 4. So S, we make what? Make come here, we make S equals to 4, right? Yes. So if we make S square, we make S 4. Therefore, we have something like this: 8 bracket open, S is 4, right? Close, then minus 17 is equals to S is 4, right? Yes. S 4 minus 4 give us 0. 0 times A will give us 0, right? So A is out already. Then will now be B bracket open. S is what? S is 4, right? 4 plus 1. So everything here be 5. 5 times B give us 5B. Then is equals to 8 times 4. 8 times 4, that is, I think that is 32, right? Yes. So that is 32. 32, 8 times 4 is 32. Okay, 32. 32 minus 17, that would be, I'm coming. 32 minus 17, that would be 15. Okay, so 32 minus 17, I'm coming. 32 minus 17 give us 15, then is equals to 5B. What I'm going to do next? Divide both sides by, I want to make B small, divide both sides by 5. So I'll cancel this. So therefore, 15 divided 3 is what? 15 divided 5 is what? 3. Therefore, B is what? B is 3. So our B is what? 3. So where you see B, you'll put what? 3. So let's look in the option. Well, which one is 5 divided S plus 1 plus 3 divided S minus 4. So let's look. That would be C. 5 divided S plus 1 plus 3 divided S minus 4. So the answer is C. So that is how you look for question regarding that is how to express some fraction into partial fraction. Yes. Just forget about numerator, right? Forget about numerator. Then decompose the fraction by turning the numerator into constant. So decompose the fraction to A over the denominator plus B over the denominator. So it depends depends on the type of question. Okay. Yes. So that is how you solve question on partial fraction. Now let's go to other questions. Now, if you look at this question on the board, I said there are 40 pupils. This question is coming out from Venn diagram. Okay, what problem in Venn diagram? Okay, so they said there are 40 pupils in a class. 30 of them study biology. Okay, so that means that okay, there are biology people that study biology are 30. Okay, then 22 study physics. Okay, 22 physics, 22. 21 study chemistry. So chemistry is 21. Then they said, okay, 15 study physics and chemistry. So physics and 15 study physics and biology, okay? So 15. Then 10 study physics and chemistry, okay? 10. Then okay, then 13 study biology and chemistry. So biology and chemistry 13. Okay, they said each student in the class study at least one of the three subjects. How many pupils offer all three? Okay, so they are looking for a number of pupils that offered chemistry, physics, biology, and chemistry, all three. Okay, all three. So it's very easy. Okay, let me just give you guys shortcuts to answer this. It's very easy, okay? So let me give you guys formula. Okay, very easy. So we are looking for number of students that study or that offer all three subjects. Okay, it's very easy. So to okay, yes, I'm coming. All right, I think let me just continue. Okay, let me continue. Okay, they said how many pupils offer all three subjects. Remember, the total number of pupils in the class from the question I just cleaned just now. Total number of pupils in the class is 40, right? Yes, so the number of pupils in the class is 40. Okay, so they are telling us how many. They said how many pupils offer all three subjects. So to do this, the formula is very. Just use this simple way. The total number of pupils normally is equals to what? This is total number of pupils equals to numbers of pupils that study only one subject. Only one subject. Then okay, total number of pupils equals number of pupils that study only one subject, such as biology, physics, chemistry, or you can say some okay, yeah, number of students that study only one subject, then minus number of pupils, that study two subjects, right? Number of pupils that study two subjects, then plus x. This x is known as we are looking. That's what we are looking for. They said how many pupils offer all three. So this s is the number of pupils that offer all three. We don't know. Okay, so total number of pupils is what? Number of pupils is 40, right? Yes, number of pupils is 40. I'm coming 40. Now what about the total number of pupils that study only one subject? Now these are number of people that study only one subject. 30 plus 22 plus 21, right? Yes. So in biology, there are 30 people that offer only biology. Physics, there are 22. Chemistry, there are 21. So if we add everything, there's number of people that study only one subject. If we add everything, that is 30 plus 22 plus 21, right? Yes. Then minus. So now numbers of people that study two subjects. If you look at it here, number of people that study two subjects, 15 plus 10 plus 13, right? Yes, so bracket open, 15 plus 10 plus 13, right? Then plus x. Okay, here is 40. So if we add everything, let's add 30 plus 22 plus 21 will give us 73. Then minus 15 plus 10 plus 13 will give us 38. What 38? Then plus x. Okay, plus x. Now 73 minus 38. 73 minus 38 is 35. 35 then equals to 40, then plus s. You are looking for s. This one will come towards here, turn to minus, right? So now 40 minus 35 is equals to x. So 40 minus 35 will give us 5. So therefore, number of students that study now how many people offer all subjects is what? There are 5 pupils that study all three subjects. Okay.